All right, well, it is 2 p.m. Eastern, 11 o'clock Pacific, so let's get rolling here, and thank you all for joining us for today's webinar to talk a little bit about empowering your resources with dataPARC. And just to set the stage here a little bit, this webinar series is kind of our more short form webinar. This will be a 30-minute webinar where we'll talk about some of the concepts that we think are really important to our customers and give some some examples of that from the product perspective, but a little bit different than the monthly education webinars that some of you have joined, where Aaron and Paul and other guests really get into specific parts of the product. Here we'll be talking more about some of the higher level concepts and ideas that we think are really important, and we'll certainly go across quite a bit of the products suite. So the first item I've got here is just a bit of housekeeping, where we will talk about the audio format for it. So if you have any questions on the right panel there, you should be able to ask some questions. So feel free to type those, and when we get to the end, hopefully we'll have some time to talk through those questions. And then just a little overview on who's hosting today. Myself, Kevin Jones, will be the main host, and then I have my colleague Ron Baldus joining us here, and Ron will be doing a lot of the heavy lifting when it comes to some of the examples and some of our customer testimonials. So, want to say hello, Ron?
Hey, glad to be here.
Okay, perfect. So certainly Ron and I have been with the company quite a while. Ron, a lot longer than I have. So certainly glad to have him. And let's go ahead and move forward here and talk a little bit about what it is we mean when we talk about empowering our resources with dataPARC. And so there's really three main elements that we think are important to make this successful. One is that it needs to be used and leveraged by everyone out there. So we want to empower the entire organization with the application. So certainly we want this to be an application for the many, not for the few. The next element we think is super important is the fact that it has to be easy. And that means easy to implement, easy to roll out, as well as easy to train and easy to use with that large, broad audience. And the last thing is the idea that it needs to be pervasive. So these things really need to live within your organization, and sometimes we use the word institutionalize data-driven decision-making. So things that really become a core part of your operations, and things that you, at the end of the day, say, hey, we cannot live without these applications. They become such a core part of what we're doing. So these are the main three elements that we'll talk about and kind of peel back the onion a little bit on each of these. So we'll start with the idea of used by everyone. So, from empowering the entire organization, what do we mean by that? Well, one idea or one element of that is the fact that we want the broad set of your audience to be using and leveraging the application. So, on the right here, the idea of our pyramid of users that we've talked about in the past, that every level of that pyramid has a set of tools and a set of applications that they're leveraging within dataPARC suite, versus a single power user in the plan. Oftentimes our customers, before they bring in dataPARC, certainly are taking advantage of various applications and have individuals who are highly competent and can really dive into the data that they need to, but that information tends to be siloed, and one or two people can really dive into the lab quality system and pull reports from it, or some people are highly proficient at thumbing through the file cabinet to find the data they need. But it's really how do we expand that from a few being experts with the data to everybody in the plant being experts with the data and empowering those masses. So that's one element of getting a broad set of people in the organization taking advantage of the application. The other is,
yeah. I was going to say
ahead,
an example of that I have to, the plant floor, we tend to don't think about all the applications that we tend to think up the pyramid a lot and the decision makers and the like, but there's so many examples at the floor level where it's just the simple things. Like we really push graphics, and you'll see some graphics examples here where we've got a lot of detailed graphics, 300-400 tags on a graphic that represent a unit operation. I did one of these. Sometimes I wonder, are we on the right track? I implemented one of these, very detailed graphic. They take a lot of work to build because there's so much on them. You got to really think it through. But I was at a plant and they went into their conference room and I was setting up to show them. They hadn't seen any of this before and had a 55-inch 4K monitor. I plugged my laptop into it and pulled up this graphic with really high level detail. And I wasn't paying much attention, and it was right next to a control room, and an operator comes walking in. He walked over, stared right in front of the graphic for about 15 seconds, and he goes, "Oh, I wondered where those heaters were." He'd been there, it's very typical, 5 or 6 years, but the plant's just so complicated they can't step back and look at it, and you put it all on one picture. So every time I get feedback like that, I know we're on the right track of going down to the floor level.
Yeah, that's a great example. So just making sure that we bring in everybody in the plant, because that's really where you get the value and create the the culture change within the plants. And then in addition to sort of tools for everybody, we want to make sure we have tools for all situations, and really about data analytics for all situations. And so in our world, that means the exploratory side, which the day-to-day, how do we make it easy to solve problems with software? And so as you ask questions of the data, how can you answer those questions easily? As well as taking advantage of modern tools and modern capabilities to have some of the predictive examples. And we're really focused on making sure we can have practical solutions for industrial problems, and making sure that these predictive tools meet the needs and meet the situations that you're used to. So we've got an example here, and Ron, I'll let you set it up.
Yes, this is a case where we're going to use sort of an advanced tool to help an operators out when a meter isn't working. So if we go into the example, we're going to go through this pretty quickly of how to build a soft sensor. So if you'll play the video. So here we have, this is an example of a lot of information on one screen, and we're brought up a trend of that process. And we have a problem in the top left where we're looking at that green tag, and that's the steam flow, and it's acting really odd. So we sync it all up to see if any of the other things are a problem, and they're not. So that steam meter is bad. So what we'd like to do is make a soft sensor to help the operator out. So what we're going to do is go down here and bring up 7 days of data. That's a good range. We're going to drag a couple of tags over onto it that we think are important. Drag one tag on, and we drag the steam condensate flow on, which would be an obvious one for predicting the steam flow. We drag those onto that 7-day trend, and then we right-click, and at the bottom we say PARC model, and we do PLS model. That's going to do a predictor, and it pops up and says, "Oh, I got an R-squared of about 0.89 up there." And the values on the constants are all 0.25, 0.26. So all 4 variables we pick are contributing to this prediction. So we're going to pull up a trend of those 4 variables plus the predicted one, which is on the very bottom. So that the bottom one, that's kind of a bluish color, that's the new predicted tag. So we're going to get rid of the model, and we're going to drag that new tag back over onto the trend that has the original steam flow on it. And then we're going to get rid of that temporary trend. Now, he's the kind of blue one up above. We're going to change it to red just so you can see it a little better. Right-click and make that a red guy. And then we need to change his range to 0 to 150 to match the steam tag. And now that's going to lay right on top of that green green tag. So we have both tags on there, the predictor and the steam. So now we're going to zoom in and show you when we lose the steam flow meter tag, how the predictor tag just keeps right on clicking and gives the operator an idea what the real steam flow is. So we hide that tag because the operator doesn't need it when it's working okay, but now it's sitting there ready to come up. We've been having lots of problems with this tag for months, and the operators lose it for longer periods of time. So this is just gives them another handle, a quick, what if or predictive tool for what that sensor is.
Yeah, so there in about 2 minutes, you identified that, yeah, we're having it's an instrument problem, and it'll take weeks or months to get that instrument replaced or repaired. So let's just build a quick predictive estimate of that value, and so we can at least know what's going on, have some visibility. Now an example of, now we talk about the idea of easy. So for us, that takes on a couple of elements. One is we want to make sure that we're leveraging existing investments. So data you have, let's take advantage of it, and not have to do rip and replace of systems that you've already put in place and spent the money on. But gaps may exist. You may have still capturing some data on a paper-based system. Maybe you're a site that does not have a historian yet. So we want to be able to fill those gaps where you're needed, but then providing you that confidence of being future-proof, so that if you do change your ERP system down the road, or put in a new lab quality system, or who knows what's coming to us with data. Your instruments may end up having a small historian inside of them for the high resolution data. Well, we want to make sure we can take advantage of that so that you have that future proof. And then lastly, of course, want to make sure it's easy to use. And those are all, those 4 items are all things that we solve with the dataPARC application. This diagram does a nice job of showing the idea of, no matter what data you have in the plant, from a historian perspective, from a lab quality perspective, ERP perspective, or machine learning or advanced analytics, are becoming new sources of data. You want to make sure that your output of your machine learning model or your advanced analytics model, that's something that you want to put into your core data visualization system. So all of these we can connect to without double storing, without additional configuration or managing of the data. We can just connect to the data as it exists. So that really solves the, leverage the investments you have and make sure that we're future proof, because no matter what comes down the road, we will have connectors to those. The next slide kind of helps us highlight, so let's say we do have some gaps at a customer site. Well, how can we leverage those? Well, on the bottom row here, we can do shift logs or manual data entry with the dataPARC platform. We do have a data historian if that's a capability you need. We can do lab quality data management if that's a capability you need. Or we can plug into the third-party data sources like we showed earlier. So any of these sources of data, whether they're part of dataPARC or part of a third-party source, plug into our transformation and all of our visualization tools that we'll continue to talk about seamlessly. So that's what we mean when we talk about filling the gaps that you have, is we can plug different tools at the bottom level as needed, and oftentimes create this hybrid environment of systems that you have, as well as systems that you need to track. So let's go back to Ron here and do another demo example.
Yeah, so we're going to look at the ease of use. We're talking about that aspect of it. And so we'd like to talk about Tag Browser. Let's give you an example of how that's used to solve a problem. So in this case, a real central part of our operation is to the Tag Browser for being able to find things. It's a pretty simple tool to use. In this case, we're at a plant that has 34,000 tags. And so we're looking at 34,000 tags. It doesn't make any difference whether you have 250,000, a million, it operates about the same speed. So they had a problem on a boiler that they said, hey, we had an efficiency problem. Can you go back and find where that occurred at so we can see what was going on at the time or if we did any repairs? So I know the BLR is the boilers start with that or have that in the name. So now we have BLR and we're have BLR 10 and 11 and 9, and we're down to 175 tags that we are looking at. But then we say star 9. I say, I know it's boiler 9. I don't know if it's 0, 9 or 9. So I do star 9, and now we're down to 41 tags. So then we type FI. I'm looking for flows. So I do FI for flow input, but that's not quite the one. They also have FT for flow transmitter. So I'm seeing the flow that's what I wanted. I've got the airflow, gas flow, oil flow. So I want to do is get several. I want to get the gas flow because I'm looking at the efficiency here. I want to look at the steam flow. So I picked that tag, and I probably need to get the oil flow because I'm not sure whether they were using it. And I double click on the left-hand side and up pops the trend for the 3 tags. So now I have the gas flow, oil flow, and the steam flow. So I'm going to go down and go back 30 days and take a look at the data. And the green tag, the oil flow, is flatline. So I X on that and get him out of the way. And I've got the 2 flag tags I'm interested in is gas flow and the steam flow. And I want to look at their efficiency, but rather than do a complicated calculation of efficiency, we just want to get a rough idea on that. So I'm going to go change the range to about 140. Of course, I played with that so I know what it is, and that's going to lay the pink tag on top of the blue tag. So they are very relational, of course, because gas and steam, and that's what you'd expect. So right on top. So a deviation from that would tell us if there was an efficiency issue. So I'm going to go back to like 700 days or so. Before I do that, I'm going to go to the time type and say, let's look at hourly data, because if I'm going to look at a couple of years worth of data, I want it to be quiet. It'd just be too noisy. So that quietened it down. And then I'm going to come down at the bottom down there and type in that I want 700 days, because they said it's in the last year sometime. So this shows 700 days of the gas flow and steam flow tags. And the pink's right on top of the blue for the most part. But there's an area in there where you can see the blue, which means the gas has gotten higher. Gas is blue. So our efficiency had to been bad during that time. So I'm going to highlight in that area. And I'm going to shift it over a little bit, because over on the left, I can kind of see where it started. So it started the first week of June over there on the left. You can see where the blue's starting to get a little higher than the pink. So I'm going to highlight from about in there and highlight over. It was high there. We had it down there for a little bit, and it gets worse and worse. And over to the next down is about, then it gets okay at the end of that. So that's the period. It started about the first week of June, and it ran for about 57 days there at the bottom. You can see the white writing. So we have our answer, 1st of June and 57 days. And now they will go look in the maintenance records and take a look at anything correlated to that time.
Okay, yeah, thanks, Ron. So a nice example of showing how we can easily find data, and then through have a self-service ad hoc analysis, solve your problem. So the third element that we talked about is the idea of these things being pervasive. So we want to make sure that the application lives and is used in a variety of ways for data-driven decision making, and it really becomes a core part of the operations, and not just a tool that's used at 1 or 2 locations in the plant or by 1 or 2 people. That really the plants say we can't live without these because they're such an integral part of our operations. So from a dataPARC perspective, that means 2 things. One is a common set of content that we use across the organization, and the other is the fact we want to be able to support both plant-wide and enterprise-wide decision making. So let's look at a few examples within the dataPARC suite of how we kind of attack and solve these items. The first one, Ron alluded to it earlier, is the idea of content for the control room for unit operations. And I'll let you intro this one, Ron, and then we'll go into another example.
Okay, this is an example of what I discussed earlier, that we're really trying to, when we are invited into a plant and we become part of the implementation, is that we think creating these displays, this display, for instance, probably came from a dozen DCS displays or 15, and they're combined into one. And it makes it so much easier to follow the flows. You got to do good work in the design so it separates areas. But the idea is you start with that graphic, and then now you can troubleshoot from it. So the next example is an example of doing that. So if we can go into that. So here we have a case where it's going to be back to that boiler again from a different point of view. This is a system header graphic for a steam system header. And we had that boiler, you said, hey, it was oscillating. Well, maybe it's a boiler's fault, maybe it's not boiler's fault. So let's go in and take a look at the steam flow. So here's a steam flow that they say was oscillating. And we know it was oscillating back in January sometime. It's not been too bad lately, but they want to make sure it doesn't happen again, and they'd like to know why. So we went back 30 days, and then we're going to pan back a couple more times and pan back to the January time frame where we know it's a little worse. You can see the blue's quite a bit wider there. I'm going to highlight a section in there that's particularly bad and zoom into it. Now we're down to the 21-hour trend, and I'm going to zoom in a little more in there. And that's an area we're going to look at. So we might widen that a little bit so we get enough data so we can actually see the variation on it. So we're going to go to 3 hours instead of 1.6. Let's back up a little bit out of there and get a little broader view. So we'll do a 3 hour. And then we're going to make the screen a little bit smaller, because what we'd like to do, we could say, let's find out if it's number 9 boiler's problem, or if it's in the steam generation or someplace else, part of the whole steam distribution system. So now we have number 9 boiler steam. So our question is it occurring in the steam generation area in general? So I'm going to drag the tag from the number 11 boiler over and show you what his steam is like, because that will tell us something. So I'm going to drag that steam down, just simply lay it over the top of the other one, and see that those oscillations are exactly right on top of each other. Well, there's no way coincidence-wise that one boiler would have oscillations that match the other when they were both feeding into the system. So most likely the variation of the header or this steam swinging is coming from the outside. So I got rid of the number 11 boiler tag, because now we're going to go farther down into the system. So there's a middle area in there where we have a 160-pound header, and we have flows going through turbines. And we checked those flows, and they weren't oscillating. But there's 2 PRVs, PRV 1 and 3, that did look like they might be an issue. So we're going to drag that steam flow through PRV 1 over, and the steam flow through PRV 3 over. Now, 1's the green guy. Nothing's going on him, so I'm going to delete him out of there. But the PRV 3 flow definitely is swinging. So now we're down to the next question is, okay, is it the controller itself that is causing the swinging, tuning, or is it some flows down below? Are they swinging that header so that it's pulling more or less steam? So we checked all of the flows except for these 2, and they were okay. But the 46,000 pound there, I'm going to drag that guy over, and I'm going to drag the 109,000. Those 2 look like they might have some variability. So I put those 2 on the trend, and we're going to drag that yellow one up to get him out of the way so you can see it. And we're going to drag the green one, click on the green one, and then get his range over there, and then slide him up and play the same game we did up top, where we lay one tag over the other, and it answers something for us. They are exactly on top of each other, and it's the same issue that can't be a coincidence they're on top of each other. They can't have something internally that both of them are just magically having this oscillation at the same time. So most likely, conclusion would be, if we're going to look farther, is that we're going to look at the controller, the PRV controller, as if it seems more obvious that that's the thing that's the problem. So what we're going to do is go over to those four, and we're going to go up to our FFT tool as a final check, and it's going to show us what the frequency is of each one of those tags. So you can see all four tags on there now, all four colors, and they all peak at exactly the same frequency. So we were right to chase it down to there and then back up at least in the middle, that they're all being caused by one thing. And most likely, whether or not we can do anything with the tuning on that, at least that's the place where we'll attack the problem.
Cool. Yeah, so that's a really nice example of starting with your structured control room display, and then from there being able to solve some problems. Kind of the second example from the dataPARC perspective, where we see our customers benefiting from kind of this institution-wide applications, would be the ability to distribute reports automatically. So since we have connections to all your data sources, we can build reports, dashboards, or trend displays of that data, and then schedule the distribution of those either on a time basis, on an event triggered basis, and then a variety of ways we can send those, whether they be to a mobile phone, an email, a printer. So it's really about getting the right information to the right people at the right time through the use of these these triggered reports and distributions. And the last example that we'll show, I'm going to go to our demo system, and I'll lead this one. Just a quick time check. I think we're probably going to go a couple of minutes over, but we should be wrapping up about 35 after the hour. So what we're going to do here is a capability that we internally refer to as our 5Y capability, and it's really just a way to structurally link associated data together. So in this example, I have a trend with some data from a boiler, but we see on the bottom left that we're having some issues with the TRS, so some of our air emissions are having some problems. Well, what the 5Y lets us do is I can right-click here, go to the 5Y, and now we have a set of content that's been linked to that parent tag. So to the TRS tag, I have linked a set of other tags. So these are, a subject matter expert or a process expert has said, okay, if we're having problems with this area of the plant, well, here are some other tags we should look at. So that's built here. But we also have the ability to link to other types of displays or other types of content. So it could be a standard operating procedure. So, high TRS standard operating procedure. It could be a troubleshooting guide. So here's, another ParkView dashboard that we have linked to this TRS tag, so we can drive people to that dashboard. Or it could be a training document that you have on your intranet. So whether it's a training guide, a standard operating procedure, a P&ID, other display content, we can create these links, and now they live in the system. So if you're you have new people coming in the plant, or you have you're losing some of your experts, this is a way to bake in the knowledge of those experts into the application. So I'll do this last example here where I launch the 5Y trend, and it shows me a trend of the the initial tag that we were interested in, and then there are the three feeder fuel feed tags and the primary airflow tag that are built on this trend. So these links are integral to ParkView, and so no matter where you're looking at that tag, whether it's in Tag Browser, on a graphic, or in a trend, we have this link content available. So that summarizes the three areas that we think are important for creating long-term success and empowering your resources with dataPARC. The fact that we are pervasive, easy to use, and used by everyone. So kind of in summary, these 5 elements, I think sum it up really well. That, we want to empower everybody, not relying on just a few in the organization to be our experts. A pervasive core part of your operations, but leverage your existing investments. It's not always a rip and replace, a project that has a lot of risk or cost. That we can use what you have today, make it easy to implement and easy to use. Any closing remarks for you, Ron?
Oh, I think the easy to use is really big to me, because if we drive it down to the floor level, it's got to be easy and fast, or people lose interest, or they've got more important things to do. So I really think driving that is a huge part of what we do.
Well, thank you, Ron, for joining, and certainly thank you to all the attendees for taking 30 minutes out of your day. Certainly, if you have more questions, please contact us, either your account rep within dataPARC, or you can email us at sales@captech.net, or visit our website, dataparc.com, for more information. Thank you, everyone, and have a wonderful day.